So one thing is the outliers, and another pre-processing is to deal with the missing values. Why do we have values that are missing? So noise we have because either there was a mistake in the data, the person provided incorrect data because they did not want to give their data, or there just is this very weird object that is totally different from all of the other objects that we have, and even if the data is correct, the object itself is so different from everything else that it looks like an outlier and we can remove it, because that will skew our analysis. If we take the average, let's say, and we have a lot of people between 30 and 50, and the one is 300 years old, and if we take the average, that will make a big difference, right? The 300-year-old guy will affect the average, and the average will be not true. He will come up maybe, what, 70? That's not true. Most of our objects is between 20 and 30 or 50. So we have to remove that. Even if truly the person was 300 years old. Still, it's very different from the rest of our objects. So why do we have missing values? Reasons is very similar. Because people don't want to give their information. So either they didn't give it, or they gave incorrect information. The reason is the same. They don't want to provide it. It could be that we merge several data sets together, integrate them, and then it happens that attributes may not be applicable in all cases. Let's say children don't have income, for example. So, or it could be that the data was not provided to begin with, so we have empty fields there. One thing we can do is to, if there are not too many of these objects, we can remove them. Another way to do this is there are algorithms that allow us to calculate or impute the missing values based on the values of the rest of values that we have in the data. We can try to predict what the values are and fill them in. Or we can design our algorithm to go through the data, and if it sees missing values, just don't use these fields and continue, carry forward, which means we need to modify our program to make sure that it is not going to crash when it encounters the missing values. So the programs that you will be writing in your project should be doing the same thing. If you see a missing value, at least you need to make sure your program ignores that and doesn't crash. So we mentioned that we could have integrated two or more data sets together. And when we do that, we could get duplicate data. Or we could just have duplicate data even if we didn't merge them. Let's say multiple email addresses or multiple phone numbers or multiple street addresses. So all of these things are something that we would do during the pre-processing step. Other things that we could do. two attributes together. That's called aggregation for the purpose of reducing the number of dimensions. So the attributes are also called dimensions for the reason of plotting them in space. So when we're plotting the objects in space, we had the first attribute on the x dimension, and the second attribute was on the y dimension, and I said we could have a z, that would be x, y, z, 3 dimensions. If we have 3 attributes, or if we have 4, 5, 6, or 200 attributes, that's the number of dimensions that we're gonna have. So the more dimensions that we have, it makes it more difficult for our algorithms to work. So they will take longer time. Let's say, if we have a table with objects x1, x2, x3, x4, x5, first attribute is A. The second attribute is B. So this has some values here. 0, 1, 5, 6, 3. B also has values. B1, B1, B2, B0, B2. So when we say plot the objects in space, we mean take the first attribute A, and the A will be on the x dimension, on the x-axis, and B will be on the y-axis. And so this is the first object has value 0 for A, so it will be here, and B1 for B. So for B will have B0, B1, and B2. For A we have 0, 1, 2, 3, 4, 5, 6. So the first object x1 has 0 for A and 1 for B. So the first object will be right here. That's x1. The next one, x2 will be, for A it's 1, for B is 1. So it will be right here. The next object, x3, for A is 5, for B is 2. The next object, x4, for A is 6, for B is 0. So that will be right here. And for x5, A is 3, B is 2. So it will be right here. So now we have these points in space. So now our objects are plotted in space. This is two-dimensional space because we get two attributes. So we plotted them in 2 dimensions. If we have attribute C, C1, C5, C3, C4, C2, then we have to show the values of C. So we're gonna have third dimension, Z. And then here we will plot the values for C. So it will be C1, C2, C3, C4, C5, C6. If we have dimensional space. I can't draw it. If we have E, it'll be 5-dimensional space. Again, I can't draw it. If we have 200 attributes, that's gonna be a problem because if we have 5 points, each one has 200 dimensions to calculate. In order for us to plot these objects, it will take a longer time and more processing. And if we want to calculate how far they are from each other, how far is x2 from x5? If we have 2 dimensions, it's easy. We subtract the values for the x for the first object from the value for the x from the second object, and then the value for the y for first object and second object. We can square that to make sure it's not negative or something, and that will give us the distance. But if it's 200 of these things to subtract, then it'll take longer processing time. And so the more dimensions we have, we can easily kill the data mining algorithm. We don't want to have too many